So now we're going to go over number 2 in the application problem. So if you need to, take a minute, read what the problem is, pause the video, read it, then play the video. So what we've got is the underside of a bridge has the shape of a parabolic arch. Okay, so underside of the bridge, so we've got this bridge, and the underside, what it's saying is this parabolic arch. Okay, so this is the area that we're talking about, and if it's a parabola, we've got a quadratic model occurring here. And it's got a maximum height of 50 meters and a width of 100 meters. So if we draw that, okay, we know the maximum height is going to occur, since it's parabolic, we know that the maximum height is going to have to occur at the vertex. And we know that it's got a width of 100 meters. So we know this is 100 meters here. And so what we can do here with this quadratic modeling is we can just impose this on a coordinate plane. So I think the best would be for us to line this up so that the start of the bridge, the underside of the bridge, okay, this obviously, that's the start of the bridge, this is the end, okay? So we've got the start happening right here, and we've got the end happening here. So this is the point 100, 0. This is the point 0, 0, if that makes sense. And so we know that, okay, if these are 2 points that have the same output, then we know right in the middle is where the vertex is happening. And right in the middle, okay, if this is 0 and this is 100, that means this right here, if this is 50 meters tall, this is the point 50, 50, because it has to be halfway between the x-intercepts that we have there, okay? So that's a little bit about what we know so far. And then it says, supports 30 meters high are placed under the bridge. So supports 30 meters high are placed under the bridge. So right now, this is 50, right? So let me write, this is 50, 1, 2, 3, 4, 5. Okay, so we've got these supports that are going to be placed 30 meters, okay? High. So, under the bridge, how far from the center are these supports? So these supports that we have for this bridge, okay, we know that they stand 30 meters high. So we know they're going to be, when the height of this bridge, this parabolic arch, is 30, okay? And what this question is saying is, how far are they from the center? So from the center would be, okay, if I brought this down to here, this down to here, what we're looking for is this. How far are they from the center? Now, we know what the center is. Okay, that's the point 50, 0, right? So what we need to figure out is, okay, what we need to figure out is, what is that x value? And we know that there is a point on the parabola, okay, we know that there is a point on the parabola where this x-coordinate is the same as this x-coordinate. Okay, so we're looking for what is this x-coordinate on this parabola when the output is 30, because that's going to be the same x right here. So we need this parabola. We need the model for this parabola. But if you notice, they don't give us a model. All they tell us is enough information to put together 3 points. We can put together that this parabola includes these 3 points. Now, if these were just a random if these were 3 random points, you would have to use 3 variable systems. But the way that we drew this, specifically imposed the coordinate plane, we can actually just use intercept form here because we have the 2 x-intercepts. The first x-intercept is 0. The second x-intercept is 100. Okay, so we have y equals a times x minus 0 times x minus 100. Or you could even use vertex form, y equals x minus h squared plus k, because you have the vertex at another point, okay? So it doesn't matter. So this is y equals, so now to find what a is, we plug in the other point that's not one of the two x-intercepts, okay? So it's going to be 50 equals a times 50 minus 0, 50 minus 100, okay? So it's going to be 50 equals a times 50 times negative 50. That's going to be 50 equals a times negative 2,500. Divide by negative 2,500. And your a value is negative 1/4. So this is y equals negative 1/4 times x minus 0 times x minus 100. Now, do you have to have x minus 0? No. If you wrote this as just negative 1/4 x times x minus 100, that's fine. So if you wrote it in vertex form, okay, the vertex is 50-50. If you plug in one of these 2 points that fall on the parabola, you would still get an a value of negative 1/4 because these are the same. It's just written a different way, okay? These equations are the same. If you FOIL this out and you FOIL this out, you're going to get the same exact quadratic model. Okay, so notice a is negative, which it should be because this is the underside of that bridge, okay? So now that I have my formula, my model, it doesn't matter which one you use, vertex form or intercept form. I'm just going to use the intercept form one because I wrote it down over here. Y equals negative 1/4 x times x minus 100. And what I want to know is, what is this point's x value? So I know its y is 100, okay? But notice, okay, I have to solve quadratic equation here. So if I'm in intercept form, perhaps that may not have been the best form to be in because I can't start solving yet until I have some form that's I'm going to be able to work with. So maybe it would have been best to be in vertex form, but oh well. So we have 30 equals negative 1/4 x squared plus a fourth of 100, that's going to be plus 25x. So this is going to be a quadratic equation that we need to solve. We can't solve like this. We're opening this thing up so we can get in standard form. So we have to now take away 30 from both sides because what we have to do here is solve. Okay? So we have 0 equals negative 1/4 x squared plus 25x minus 30. If you don't want to use a fraction in the quadratic formula, we talked about creating a multiple equation. Okay, we can multiply this equation by 4. It's going to give us 0 equals negative x squared plus 100x minus 120. Now we can just use the quadratic formula. Now when we set this equal to 30, okay, I pointed specifically to this one, but we just want the 2, we're going to get the 2 x's, okay? We can see there are 2 supports here because there are 2 points on this parabola that have a height of 30. So we're solving for when the height is 30 on this parabola, and we know we're going to actually get 2 answers here. We're going to get something close to 0, and we're going to get something close to 100, okay? 100 squared minus 4 times negative 1 times negative 120 all over 2 times negative 1. Okay, so that's going to give us, I'm going to erase this. Okay, we can use our calculator. This is going to give us negative 100 plus or minus the square root of something over negative 2. Let's find that something. That's going to be 100 squared minus 4 times negative 1 times negative 120. That's the square root of 9,520. Okay, so that is not a perfect square. So what we want to do is round this. This is going to be negative 100 plus or minus 97.57 all over negative 2. So now let's get our 2 values of x. That the output would be 30. So negative 100 plus 97.57 divided by negative 2 puts us at 1.215. And negative 100 minus 97.57 divided by negative 2 puts us at 98.785. Okay, so we know that this is the value of, this is 1.215, comma 30 and this is the point 98.785, comma 30. So we know that this support, how far is it from the center? This is at 1.215, right? And this is at 98.785 meters from this point here. So how far is it from the center? Well, if the center is at 50, okay, just subtract 50 minus 1.215, gives us 48.785 meters. And remember, these outputs are the same, so this has to be the same thing. This still has to be 48.75. We'll check 98.785 minus 50 puts us at 48.785. So how far is this support beam from the center? Okay, it's going to be 48.785 meters from the center.